speakers and chairpersons for such a wonderful session. So there's a slight change in the schedule. We'll be moving on to the next session now, which is the Guha Oration, and then after that we'll come back to the glioblastoma session. So may I please invite the chairpersons, Dr. Tejpal Gupta and Dr. Purna Kurkure, for the Guha Oration.
Thank you. So now we come to the Guha Oration, and may I request Dr. Chitra Sarkar to please come on stage and introduce the Guha Orator. Ma'am, please.
Can I have the slides? Good evening. Welcome to the Guha Oration, which we look forward to every year as a very important event of the ISNOCON. It is my proud privilege and honor today to introduce to you all the orator of 2022, Professor David Louis. He is the Benjamin Carson Professor of Pathology at the Harvard Medical School, Pathologist-in-Chief at the Mass General Hospital, Chair of Pathology at Brigham and Women's Hospital, Inaugural Chief of Enterprise Pathology at Mass General Brigham since 2022. Under his chairmanship, the MGH department has become a national leader in molecular diagnostics and pathology informatics, leading to a novel initiative in computational pathology. His clinical neuropathology practice and research focuses on brain tumors, particularly molecular diagnostics and glioma classification. And he is a pioneer in this field, and the WHO 2021 classification, which is the theme of this of our conference this time, he has been the pioneer in this. His group first demonstrated the molecular approaches which could subdivide malignant gliomas and predict the therapeutic response, leading to the worldwide adoption of molecular testing for the glioma management. He has published more than 300 original articles, reviews, chapters, and of course, books. Most importantly, he has served on the 2000 WHO Committee on the Classification of CNS Tumors, co-chaired and was the primary editor for both the 2007 and the 2016 WHO classifications. We have all heard of the C impact in between the 2016 and the 2021 classifications, which formed the basis for the 2021 classifications. So he chaired the CNS committee of for the International Collaboration on Cancer Reporting and was the founder and inaugural chief for C impact now. And of course, he was on the expert panel for the 2021 WHO classification. So a warm welcome to Professor David Louis to deliver his oration today evening in the ISNOCON 2022. Thank you so much, Dr. Louis, for accepting our invitation. And it's indeed an honor and privilege for us to hear you today. Thank you.
Thank you, Professor Sarkar, for that very kind introduction. Can you hear me? Can you hear me now?
Yes, sir, we can hear you.
Oh, great. And can you see my screen yet?
So can I request you to make your slides full screen, sir? We can see your slides. But can I request you to full screen, sir? Yes, sir. Now it's full screen. Thank you so much.
Okay. Well, again, thank you, Professor Sarkar, for that kind introduction. And thank you for giving me the honor of being this year's Guha Orator. I knew Dr. Guha personally and knew him for many years, since he and I were trainees at about the same time I first met him when I went over to the Brigham and Women's Hospital for a research discussion. He was spending some time with Peter Black at the time, and we were in a small meeting together of about 5 people discussing some project. And afterwards, Ab and I walked out of the room together, and that started a friendship and some collaborations that lasted for many years. He was not only an impressive neurosurgeon and brain tumor scientist, he was also a very nice person. And he had a remarkable ability to pack large amounts of information into his presentation. So the challenge for me today is to try to put a fair amount of information into my lecture. I'll start by saying that the talk, not the last 2 talks, but the one just before that, was packed with information about the 2021 WHO classification. And so in order to save a little time, I've taken out some of the basic aspects of my talk. But what I'd like to do for you today is to take a big picture look at the 2021 classification. I realize that it's an audience that has not only pathologists, but oncologists and neurosurgeons, radiation oncologists. And so I'll try to make my talk not as much pathology oriented, but explore firstly, what are the big changes in the 2021 classification, and then spend a good amount of the talk on what are the problems that have been raised to me? What are the frequently asked questions about the classification that I've gotten? I've entitled the talk WHO CNS5. CNS5 is the 2021 classification, Climbing Up the Other Side of the Valley. And I'll explain to you what I mean by that. So before beginning, I like to begin all of my, before beginning on the 2021 classification, I like to begin all of my talks talking in general about why it's important to classify human tumors. For most of us, we relate to the care of individual patients, and we've just heard about this in a number of lectures, estimating prognosis and guiding therapy based on the pathological classification. But when you start thinking about it more, you realize, again, as we heard about in the last couple of presentations, the conduct and interpretation of clinical trials is also absolutely dependent on accurate classification. When you step back even further and think about experimental studies in mice or in petri dishes, again, if you incorrectly classify the cells or the tumors in that, you may derive incorrect conclusions that then may guide clinical trials in the wrong way. So even experimental studies are dependent on accurate classification. Stepping back even further, it's important to realize that population-based studies like epidemiology are ultimately dependent on accurate classification and coding of diseases, and that these types of epidemiological studies may actually implicate etiologies. And lastly, but not least, the allocation of resources by governments and health insurers to support healthcare is also dependent on accurate classification. As a result, the periodic revision of tumor classifications has diverse and important effects, many aspects of not only individual, but on population health. But it's also very important to realize that all tumor classifications are imperfect. They're imperfect representations, and they only reflect the state of understanding at a particular time and the interpretation of limited numbers of experts. They are very much to be thought of as works in progress. When it's thought, how do you get from basic biomedical research to understanding a clinical significance of something, and then put that clinical significance into practice? The analogy's been made to peaks and valleys. To get from basic biomedical research to understanding some clinical significance, you go through what's called Valley 1, and then to take that clinical information and translate it into routine care, you go through Valley 2. And these have been called the translational valleys of death. They're very hard to cross. I'll give you the example from my career. We first demonstrated in 1993 that gliomas could be subtyped genetically. But it was only in 1998 that we showed that 1p19q could subdivide oligodendrogliomas into those that were more responsive to therapy versus those that were less responsive. So showing some type of clinical relevance to a basic science discovery. It then took quite a while to develop tests and to begin to use the tests widely for clinical purposes. And it was only in 2014 that we began international discussions to use it for official classifications. And in the 2016 was the WHO was the first worldwide approval of use of a test that was a molecular test for classification. So you can see this is over 20 years from the time that a discovery is made until the time it's put into clinical practice. When you think of where the WHO classification lies, it lies in the second translational valley of death, right here. And so as we think about the challenges of implementing the WHO and making the changes for the WHO, we think about moving something from general clinical relevance to widespread practice. It's not only the WHO that participates in this. When you think about how we got from the 2016 WHO, which was the updated 4th edition, to the 2021 5th edition, it really was dependent on all of the activities of C-IMPACT. This was the consortium to inform molecular and practical approaches to CNS tumor taxonomy. So it's not simply, oh, 2016 happens and then 2021 happens. There's a large amount of debate that went on in between those two. So if you then ask, what are the major changes for the 5th edition for 2021? I like to divide them into general changes and specific changes. There are changes in the way the tumor classification is organized, its taxonomy, the way the tumors are named, the nomenclature. But what I'll speak to you right now about is tumor grading, the use of NOS and NEC, and integrated and layered diagnoses. So let's start with tumor grading. There have been some major changes. The first is the use of Arabic rather than Roman numerals. This seems like a silly minor change, but it's actually important. It will then make the CNS system conform with other WHO grading schemes for other tumor types. And it'll importantly decrease the likelihood of making a typographical error between a Roman numeral 1 and a Roman numeral 2 when grading within types. So what is grading within types? This is a key thing to understand no matter what subdiscipline of neuro-oncology you're in. As you heard about a couple of talks ago, we now think about astrocytoma IDH mutant as a single entity, and then within that entity, within that type, we grade it as 2, 3, or 4. This affects the nomenclature. For example, there is no more anaplastic astrocytoma. It just gets subsumed in the grade. The grade itself is now determined not only by histology, by molecular testing as well. For example, glioblastoma is also defined now by being IDH wild type and then getting a grade of 4, and we'll talk about this in a little while. Nonetheless, it's important to realize that it still is not strictly histopathological and molecular grading. There's a clinical component to it. And the reason that's so important is that, for example, when you look at astrocytoma IDH mutant, we don't begin with a grade 1. When you look at tumors in the rest of the body, if it's a malignancy, let's say a soft tissue sarcoma, once you call it a soft tissue sarcoma, it gets a grade of 1 if it's low grade, a grade of 2 if it's medium grade, a grade of 3 if it's high grade. But in the CNS, we've always reserved grade 1 for benign tumors like pilocytic astrocytomas. And so we didn't want to completely confuse the field, and therefore a tumor like astro IDH mutant, there is no grade 1. It still is this clinico-pathological grading of 2 through 4. And that's why we've encouraged the use of the term CNS WHO grade rather than just WHO grade. It's not a pure clinical grading system because a tumor like germinoma is still grade 4 despite it being cured the majority of the time with radiation. And then we also said for the first time that in situations in which grade could confuse clinical practice, one can omit the grade. So for astrocytoma IDH mutant, you grade it from 2 to 4. Grade 2 has an IDH or IDH1 or IDH2 mutation. The tumor is well differentiated, it's diffusely infiltrative, and it lacks histological features of anaplasia like mitotic activity. And then it lacks microvascular proliferation necrosis and the molecular marker of CDKN2AB homozygous deletion. To go to grade 3, it usually begins to acquire anaplastic features histologically, just like we distinguish grade 3 from grade 2 in the past. And we also use significant mitotic activity. But the very high grade features of microvascular proliferation necrosis and the molecular high grade feature of CDKN2AB deletion are absent. And then for grade 4, which used to be what we called glioblastoma IDH mutant, one of those additional molecular or histological features are present: microvascular proliferation, necrosis, or the homozygous deletion. Contrast that with glioblastoma IDH wild type, which is defined as an IDH wild type diffuse astrocytic glioma with any one of these 5 features, 2 of them histological and 3 of them molecular. So again, the term glioblastoma now is reserved for an IDH wild type tumor. So it brings up this slight confusion. Is a tumor a glioblastoma or not? And if I were to say which slide in my whole talk is the most important, it's this one, because it illustrates the 2 scenarios that have changed the most between 2016 and 2021. So the first is a scenario in which you have a diffuse astrocytic glioma. It does not have microvascular proliferation or necrosis. So it's not what we might have called glioblastoma histologically in the past, but this tumor could be a glioblastoma if it has EGFR amplification, TERT promoter mutation, or +7 - 10. That would be called an IDH wild-type glioblastoma, even though it's not histologically named a glioblastoma. And the opposite scenario is the one in which you've got a tumor with microvascular proliferation or necrosis, something in the past we would have called a glioblastoma. That in the 2021 is not a glioblastoma if it has an IDH mutation, because then it would be an astrocytoma IDH mutant, CNS WHO grade 4. And the reason we've separated these out is we now know that biologically, the tumors with IDH mutations are entirely different from those without. The goal is to clarify that when you do clinical trials, you have to separate out these entities. When you then begin to manage patients, you really have to think about these not as variations of a single entity, but really as different entities. The other key concepts are these ones of NOS, which is not otherwise specified, and NEC, which is not elsewhere classified. We didn't make up these terms. These are WHO terms, but we are now using them in very different ways in the 2021 classification. So I'll tell you about that and why the most effective way is to use them in these integrated and layered diagnoses. So let's talk about that for a moment. I like to think about NOS and NEC as this traffic light. If you've got an integrated WHO 2021 diagnosis, that is the histology and the molecular information all fit together. It fits, looks exactly like it's described in the book. You go ahead and you make that diagnosis. But what if you don't have the tests available? You don't have access to the testing? What if that's the situation? In that case, you give it an NOS diagnosis, not otherwise specified, based on the histology. And this creates a red flag to the oncologist seeing the case, to the pathologist seeing the case next, that the case is not fully worked up. Now, it may be not fully worked up because one person couldn't order the test, but it may also be because you ordered the test and the test didn't work for some reason. NEC, on the other hand, not elsewhere classified, means that the necessary diagnostic testing was performed, but the results don't readily allow for a WHO diagnosis. This is what in the past we've called descriptive diagnoses, where it's very important for the pathologist to be in close contact with the treating doctors to explain what the more important aspects of the case are relative to the diagnosis. So NOS, NEC, and actual integrated WHO diagnoses are very important to understand, and there are distinctions between them that should guide care. We feel that the best way to show this is in what's called a layered diagnosis, where you have your integrated diagnosis, typically WHO, NOS, or NEC on the top, then the traditional histology, then the CNS WHO grade, and then the molecular information if it's available. So here's an example of an ependymoma, supratentorial. But when they tried to extract DNA from the formalin-fixed paraffin-embedded tissues, the DNA was not of sufficient quality for sequencing, and insufficient tissue remained for FISH studies. So you couldn't do the test, and therefore you label it NOS, and that alerts the clinician that it might be somewhat different from the typical supratentorial ependymoma that might have a fusion, for example. Here's another more complicated example. It's a diffuse low-grade glioma, MAP kinase pathway altered, and this had a specific molecular subtype of being FGFR1 TKD duplicated. Histologically, however, this looked like an oligodendroglioma. When you have such tumors, we're actually not exactly sure of the grade. So this is one that I mentioned you could not assign a grade. And then you list the molecular alteration. I hope that that makes sense to you, this notion of changing tumor grading, the importance of using NOS and NEC for any diagnosis. In 2016, it was reserved for specific diagnoses. Now you can use those terms as you need them, and to display these in integrated and layered diagnoses. So let's briefly go on and talk about specific changes within the tumor groups. And again, I've cut out some of this because of the very nice presentation we heard just about an hour ago on this. Usually when WHO classifications come out, most of the focus is on newly recognized types. These are obviously not new tumors biologically, but they're newly recognized. In the gliomas and the glioneuronal tumors, there are 14 of these entities, and you see them listed here. These are entities that were not in the 2016. And as you cast your eye over this, I won't go over them in detail, as you cast your eye over these, you realize that almost all of them are quite rare entities. That's important to understand. When you look at the other tumors, those that are not glial or glioneuronal, there are 8 new other tumors in the 2021 classification. You see them listed here. And again, all of these are quite rare tumors. The 3 tumors that are listed in italics are what we call provisional entities. There's good evidence that they are real, but not much evidence in the literature. So we expect them to be adapted as full entities as more data comes out on them. So let's talk about some of these. For the glial, glioneuronal, and neuronal tumors, there are 6 types. There are the diffuse ones, which are now divided into adult type and pediatric type. The type there is important to understand that these are not adult tumors and pediatric tumors, but they are adult type tumors and pediatric type tumors. The pediatric type ones are divided into low grade and high grade. And then there are the usual other groups of gliomas. These have been in the classifications for a long time: circumscribed astrocytic gliomas like pilocytics, glioneuronal and neuronal tumors, things like gangliogliomas or neurocytomas would be in here, and the ependymomas, of course. The major changes have been to these top groups. We now divide the gliomas into adult type and pediatric type. The pediatric type is divided into low grade and high grade. As I'll show you, we've simplified the classification of the common adult type ones. And as I've already talked to you about, the nomenclature and grading of these common adult type diffuse astrocytic gliomas has changed. So if you look at those adult type diffuse gliomas, there are only 3. That's amazing. Astrocytoma IDH mutant, oligo IDH mutant and 1p19q co-deleted, and glioblastoma IDH wild type. For the pediatric type diffuse low-grade gliomas, there are 4 types. For the pediatric diffuse high-grade gliomas, there are also 4 types. So a rather limited number, but as I'll show you, there's a lot of diversity within the groups. So let's talk about the adult type diffuse gliomas. In 2016, there were over 20 entities listed in this category. Now there are only 3. The reason is we didn't list subtypes. Those are in the chapters. We didn't list the NOS types specifically because NOS and NEC can be used anywhere. The IDH assigns a diagnosis. It doesn't modify a diagnosis. We now grade within types, as I've described. The diffuse midline glioma has come out into the pediatric type high-grade diffuse gliomas, and oligoastrocytomas have now finally disappeared. So as a result, as a result, you only have these 3 entities left: astrocytoma IDH mutant with its 3 grades, 2, 3, and 4, oligo IDH mutant and 1p19q co-deleted with its 2 grades, 2 and 3, and then glioblastoma IDH wild type, only 1 grade, grade 4. When you look at these pediatric type diffuse low grade and diffuse high grade gliomas, I'll draw your attention to these 2: diffuse low grade glioma with MAP kinase pathway alteration and diffuse pediatric type high grade glioma H3 and IDH wild type. And I draw your attention there because these are interesting. These are rather nebulously named types, and each one requires further workup. So for the diffuse low-grade gliomas, you need to look at certain genes, and you need to exclude alterations of other genes. And for the pediatric high-grade ones, you need to do additional molecular examinations as well, including in some examples, you might have to go on to do methylome profiling. And I'll discuss methylome profiling in a moment. So the key points, therefore, are use the layered reporting format because it explains what have become complicated diagnoses. Use WHO diagnoses, and if it doesn't fit nicely into a WHO diagnosis, use NEC or NOS for the integrated diagnosis in the layered report. Grade within types now. And because this has gotten complicated, there are some good tables or flowcharts in recent publications, and I highly recommend using these until people get familiar both with generating these reports, but also as a treating oncologist, treating neurosurgeon, to understand these reports, look at these flowcharts. So I'm coming back to the diagram that I showed you at the start, which talked about Valley 2. And as I said, WHO is concerned with Valley 2, C-IMPACT is concerned with Valley 2. I don't have time to talk about the International Collaboration on Cancer Reporting, ICCR, which is also concerned with Valley 2. But moving up the other side of the valley is, it's a hard task. It feels like you're pushing a boulder up a very steep hill. And so what I thought I'd spend the rest of the talk trying to clarify is the process of pushing that boulder up the hill. How do you get people to use a new classification once it's been generated? And I'll answer two questions. What needs to be clarified and perhaps adjusted? And what are the structural barriers? So firstly, what needs to be clarified and perhaps adjusted? I rephrase this by asking, what are the most frequently asked questions, the FAQs, about implementing CNS5? And this is a personal experience. Since the publication late last year, I've gotten many emails and many questions at the ends of talks about struggles that people have had. And so what I've done here is to assemble those frequently asked questions, and I'll go through them with all of you. So I still get asked this a fair amount. What do I do if I don't have access to molecular testing? And the answer there is to use NOS. If your institution doesn't have it, and you see the use of NOS there, you'll know that there may be more information that can be derived from that tumor. What do I do if the histology and the molecular findings don't match to produce a clean WHO 2021 diagnosis? Well, again, that's when you use NEC, when things don't match. And I know I've mentioned this in the lecture, but I still get questions about this, so I think it's worth repeating. I then often get people saying, well, but NEC is not satisfying. I'd rather try to get it into a specific diagnosis. And my answer is yes, you're right. NEC is not satisfying, but in reality, it's much more honest than trying to force it, to shoehorn it into something that it is not. The treating clinician or the clinical trial needs to understand this is not a classical example of X or Y, and I may need to adjust my treatment, and I may need to reconsider whether this patient should actually be in the trial. So while I agree it's not satisfying, it's being quite honest. So if you don't have these molecular tests, but you can send them out for molecular testing, I get asked, if I send my cases out for IDH analysis and the results take a few weeks, is it true that a diagnosis of glioblastoma has to wait for a few weeks? Well, yes and no. The formal diagnosis, in fact, has to wait for IDH results, or else it's NOS. But preliminary diagnosis doesn't have to wait and should not wait. the pathologist should be communicating with the oncologists and letting them know that it's a grade 4 astrocytic tumor in most situations, and that will allow them to go ahead with treatment planning, even if you have to wait a while for the final actual diagnosis. Clinical trials, however, that require a diagnosis of glioblastoma will need to adjust their criteria going forward, and people have already begun to do this. From the clinical trialists, we've heard a lot of thanks for separating out these glioblastomas so clearly now and not confusing them with the IDH mutant tumors. So let's talk about a specific example I've gotten asked about a fair amount. How do I evaluate a grade 3 appearing tumor? So it looks like grade 3. It's anaplastic appearing, it's hypercellular, it's mitotically active, but it's IDH wild type. So it doesn't meet the histological criteria for glioblastoma, but it is IDH wild type. So there you have to evaluate for the molecular features of glioblastoma, and sometimes for the molecular features of other high-grade gliomas like H3. The molecular workup will often here clarify the grade. Is it grade 3 or grade 4? But if not, you just grade it on the basis of the histology, which would be a grade 3. What about this situation? This is, I think, the more tricky one. How do I evaluate a grade 2 appearing tumor? So it doesn't have anaplastic appearing cytology. It's not particular hypercellular. It doesn't have mitotic activity of any significant amount. It's diffuse, it's astrocytic, so you expect it to be IDH mutant, but instead it's IDH wild type. These are much more difficult than the last scenario I talked to you about. So this is really important that in young patients in particular, you need to evaluate them for the molecular changes of pediatric type diffuse low-grade gliomas. In our experience, these will sometimes turn out to have alterations like BRAF or like FGFR1. You then can also evaluate them for molecular features of glioblastoma, but in my experience, when it's grade 2, this is actually quite unusual to see frank glioblastoma molecular features. But if you do that and you don't find anything, either features of pediatric type or features of glioblastoma, then you designate it as NEC. And this acknowledges that the likely behavior is not well understood. We really don't understand these tumors. You can grade it then on the basis of the histology, give it a grade 2, and note that a clear grade has not been assigned by the WHO. Or you can simply avoid giving a grade and state that a clear grade has not been assigned. Again, the most important thing is clear communication between the pathologist and the treating physicians. This is another situation where the subject of methylome profiling comes up. Should you go ahead and try to do methylome profiling if you have it available? So I'll talk about how the WHO addressed methylome profiling, because I get asked this question a lot. We used it more as a discovery tool than a diagnostic tool. There are very few entities in the 2021 classification where you actually need methylome profiling to make a diagnosis. On the other hand, there are entities that were initially clarified in the literature through methylome profiling studies, but now there are alternative ways using histology and genetics to make that distinction. So what do you do if you don't have methylome profiling at your hospital? Well, you do the same as I do. I don't have methylome profiling at either of the hospitals that I oversee. We send it to another place. In our country, we send it to the National Cancer Institute, and there are a few other places around the country that'll do it, but the National Cancer Institute will do it for free for us. And so we send it out, and it's not widely available in our country. So if you can send it out, that's what you should do. where do I think the future will go with methylome profiling? I think it's not going to replace standard diagnostics. It will find its niche, just like all other tissue-based techniques have over the past 100 years. When, for example, electron microscopy came out or immunohistochemistry, there were fears that it would completely replace the way we do standard classification using the microscope. Similarly, molecular diagnostics and expression profiling was completely going to replace things. As people say now about methylome profiling, I don't believe that at all. I think there'll be specific instances where the pathologist will turn to methylome profiling, just like he or she currently turns to doing a FISH assay or some other immunohistochemical assay. And then I get asked the funny question, what do I think about methylome profiling? Because it's become quite a controversial issue. My opinion is that it's a powerful technique. I actually think it's very similar to histology for the following reasons. It was controversial and hard to use at first. If you look at the literature 100 years ago, in the 1920s and 30s, there was a big controversy about whether the microscope would catch on. Many people thought it was way too complicated to expect doctors to use a microscope to classify tumors, and that the gross appearance was more than sufficient. So similarly to the kinds of things that people are saying about methylome profiling now. It's also similar to histology because it analyzes thousands of variables, thousands of methylated loci in the genome, just like when the pathologist looks at a slide, he or she looks at thousands of different variables under the microscope. Individually, any of those are of unclear significance. There's no way any pathologist bases a diagnosis only on the mitoses, for example. And similarly, you can't base a methylome profile on only one area in the genome. That's very different from immunohistochemistry or a genetic analysis, which you look for a specific alteration. Is there an IDH mutation present or not? It's a yes, no kind of answer rather than an analysis of thousands of variables. Like histology, methylome profiling uses a brain to see patterns. In histology, it's a pathologist's brain. In methylome profiling, it's the brain of the computer doing some type of artificial intelligence to pull out the pattern. And that brain, whether it's a histology trainee, a pathology trainee, or the computer, must be trained to recognize patterns. And then lastly, it compares the findings with a reference set. You can't automatically say whether something's normal or abnormal. You have to compare a picture of the brain with a picture of the normal, a picture of a brain tumor with a picture of the normal brain to know whether the tumor is abnormal. Similarly, with methylome profiling, you need to compare it against all other profiles that are known in the literature. So that's the way I would encourage people to think about this new technology. It'll find its niche. I don't think it'll replace what we do. And in a sense, it's similar to histology. So let me ask you two questions to get your minds thinking about what I've discussed. Here's case one. It's a diffuse glioma. It's got an IDH mutation, ATRX loss, so sounds very astrocytic. No 1p19q deletion, so it sounds astrocytic, but there's no information about CDKN2AB homozygous deletion. So I've been asked, what do you call this? Is this astrocytoma IDH mutant NEC or NOS? And another case, what do you do if it's histologically grade 2 or 3, but it's IDH wild type, and you can't do the other molecular tests? Is that NEC or NOS? So if you take the first scenario, well, the most important thing that I said is you need to put a red flag on it. You need to tell anyone reading the report that it's not a classic, fully worked up example. The most important part is that the red flag is there to state that this is not a full 2021 WHO diagnosis. But case 1 has a clear diagnosis of an IDH mutant astrocytoma, and really all that is missing is the CDKN2A deletion information. That contributes to the grade, not really the diagnosis. So my preference, it's not a hard rule, but my preference would be to use NOS here, because all that's missing is a single molecular test and a final integrated grade. For the other example, again, the most important thing is stating what you know and adding that red flag, whether NOS or NEC. That's the most important aspect. In this case, however, it would be really important to look for other alterations like H3, like BRAF. And so the diagnosis in this situation is actually quite uncertain. And so I would have a strong preference in this case to use NOS. I've gotten asked, where in the report do histological variants go? Do they go in the integrated diagnosis or histology? I had a case recently of an IDH mutant astro. It was CNS WHO grade 4, no question, but it had giant cell phenotype and a primitive neuronal component. So you could put it in the integrated diagnosis as a subtype. So here you've got astro IDH mutant, CNS WHO grade 4, and put the subtypes in there. You list it as a high-grade diffuse astrocytoma with necrosis, it's grade 4, and you list the molecular alterations. Or you could put the histology under the histological classification and simply put it there. I actually don't have great preferences one way or the other. And that's the beauty of these layered reports, is that it actually doesn't matter that much whether you put it in the top or in the second line, because the person reading the report's going to see all of it. What do you do on a frozen section if it looks like a grade 4? In the past, we would just say glioblastoma. But now, if it's IDH mutant, in the long run, it's not going to be a glioblastoma. So what we say is diffuse astrocytic glioma, grade 4, await further workup, and that allows us more time. What do you do with the histological diagnosis for astro IDH mutant grade 4 if the histology looks like a glioblastoma? And wouldn't it be confusing if the top line said astrocytoma IDH mutant grade 4 and the second line said glioblastoma? So we don't use the term glioblastoma anymore for that histology. We say diffuse astrocytic glioma, and then we list the histological features that correlate with the highest grade. What do we do with the histological diagnosis for a GBM that's IDH wild type? If the histology doesn't look like glioblastoma, again, we just describe the findings. From a diagnostic point of view, your diagnosis is in that integrated diagnosis line. The second line, which is histology, can be simply descriptive. So this is a verbatim question. Convincing new types of brain tumors are reported from time to time, but have not yet been included in the 2021 classification or have come out over the last year. Do I still need to report them as NEC, or do I use the terminology recommended in the published articles? And I would say both. Use the new term and also include what the diagnosis would be according to 2021 WHO, because the coders will find it very important to enter proper WHO diagnoses with the corresponding ICD-10 codes. I've been asked that pediatric type high-grade gliomas can occur in adults. The text does not provide age ranges. Yes, that's true. We use the term pediatric type, not pediatric. These tumors can occur in adults. It's just that they're more commonly found in children. Given the uncertainty about some of these rarer entities, we didn't provide age ranges, but it's hoped that future editions, as more are reported, that we'll have more information about that. Some of the essential diagnostic criteria, I've been told, are confusing. The principles seem different across different tumor types and chapters. This was the first WHO in which a single editor was not responsible for the overall book. There were multiple editors and each had a different section. This is just the way the new person running the WHO series has changed things. I personally thought it was not a good way to do things. And as a result, there is a lot of variability over the 2021 Blue Book, which was not the case in the past. So to me, this is the biggest problem with CNS5, resulted from a lack of a single responsible editor and how the final edits were made. Remember that early editions of the WHO, 79 and 93, were just definitions and illustrations, with the great majority of deliberation time being devoted to establishing these clear definitions. Right now, the WHO Blue Books are textbooks, and more time is spent filling in the details of the text than actually deliberating on the definitions. So this is a possible early topic for C-impact going forward. So will C-impact continue? I get asked this question a lot. Yes, the early stages have started under Peter Vesseling in the Netherlands. I'm not going to be the steering committee chair. We are currently working on steering committee and clinical advisory panel membership, currently working to assemble topics, and then we will assemble working groups. So in the interest of time, I will go quickly through the next part, but there are structural barriers to implementing some of this. There are relatively few studies of worldwide diagnostic capabilities, but there have been some very intelligent and creative adaptations after the 2016. I'll point to the one from India by Professor Santosh as the first author back in 2019. More research is needed in this area, and a colleague of mine from the UK, Henry Llewellyn, is diving into this in more detail. But I wanted to draw attention in the closing minutes to this really wonderful set of review articles that have come out by Drs. Sarkar, Uppin, and Mahadevan in the Indian Journal of Pathology and Microbiology. It's a whole special issue, and it looks at the 2021 classification, at its challenges and opportunities. And when I think about the best way to tackle these, I really can't do any better than what was put forth in this really excellent special issue. And I love the quotes, and so I wanted to quote them back to you. Every challenge contains within it the seeds of opportunity and growth. It is challenging to implement that. And what they write is that the major challenge relating to CNS5 is the practical applicability of classifications in low and middle income countries, where there's restricted availability of molecular testing facilities. It's becoming more and difficult over time to keep pace with these rapidly increasing markers. But then, very importantly, they add, how should we react to these challenges? There are two options: either fret over the lack of facilities, or take these challenges positively and turn them into opportunities to grow. I just love the way that's phrased. And three approaches are outlined. You can develop country region specific evidence-based guidelines. This is really brilliant. You can develop a few referral molecular diagnostic labs in a country. And the example that I gave you, that there aren't any hospitals in Boston that can do methylome profiling. We use the laboratory in Washington, DC in the National Cancer Institute. So we're following option number 2 there. And then very importantly, to change the way training occurs in pathology so that pathologists are very comfortable with all of these new technologies. And what they conclude is that the molecular revolution shouldn't be taken as a threat to traditional histomorphology, which is what I believe. It should be taken as an opportunity for pathologists to accept their changing role and to expand their horizons. And then lastly, they quote the great Indian philosopher, The philosopher says, let us not lower our goals to the level of our abilities. Instead, let us raise our abilities to the level of our goals. Truly an inspiring message in this situation. I won't go in just because of lack of time into details of what Henry is proposing, but it's important that in many places, particularly in Africa, it's not only that they don't have access to technologies, but they don't have access to basic aspects of what it takes to run a laboratory. And so Henry is going to be working to try to understand that, and what are some ways that countries that are really have limited, very lower abilities to do medical evaluations, how they can work as well. So I hope I've given you some indication of the problems, how questions are being answered, and how barriers are being overcome. And in concluding, I just want to thank all of the members of C-IMPACT over the past 5 or 6 years. C-IMPACT was a massive effort with many different people involved. And then to thank the other editors for CNS5. The editors are listed here, but there were many more authors, including some wonderful authorship from some of the colleagues here that are at this meeting. And with that, I will thank you all for your attention. I'll thank you for giving me the honor of a talk in Ab Guha's name. It really means a tremendous amount to me. Thank you.
Thank you, Dr. David Lewis. I think this was a really wonderful oration. And may I now request Dr. Kurkure to, Dr. Kurkure, can you, Dr. Chitra Sarkar, can you please come up? The plaque. So we have a e-plaque, but we also have a physical plaque that we will be sending to you, sir, when one of us actually visits the US or you come down to India. So can we have the plaque, please? The e-plaque, can we display the e-plaque?
Thank you. That's very kind. Thank you very much.
Thank you, Professor David Louis, for this wonderful oration and taking us through the whole WHO 2021 in a very remarkable way, answering the frequently asked questions which all of us have in our minds. And thank you very much for putting that editorial of mine, which made my day today. Thank you so much, and hopefully to see you in India someday.
Thank you very much. Bye-bye.
Just a minute, Dr. David Louis. This is your plaque.
Oh, wonderful. It looks lovely from here.